Right, ladies and gentlemen, we're going to start the session now. Just a quick bit of housekeeping. We encourage you to obviously utilize the Etherpad. There's the link. You can also get access to the link on this Etherpad on the schedule, on the OpenDev schedule, so please join there. Other than that, I'll turn you over to your moderator, Gregory.
Hi there. My name is Gregory. I'm from Inmarsat. The topic here in this session is the next control plane session, and it's about autonomous workload management. So we've been discussing during the last two sessions a little bit about what is actually the edge and how we can slim down the control plane with very interesting points. In this session, I will try, let's say, to step back a little bit and think just maybe some specific use cases, which is maybe a subset of the whole edge scenarios that we were discussing today, which is focusing on the autonomous behavior for the workload management. So what's the problem in hand? I have put already some notes in the Etherpad. Feel free to comment. Just some ideas there to start with is that the definition of that scenario is to orchestrate a workload at the edge, which might be, as we saw, fixed or mobile, might be a run, or might be an absolute CPE, mobile CPE device. I think it was mentioned also before, having heterogeneous devices and platforms, which is, I think, a realistic assumption. We also mentioned about multi-tenancy. I think it's a valid also assumption to expect multi-tenancy in this workload at the edge, in the workloads at the edge. And we might have independent management of these workloads, but also could be grouped in clusters. And this is also another assumption, considering the scale of it. We could expect that we would like to see a whole set of edge devices and platforms that we would like to manage and orchestrate workloads on them. So those are some points that I think could express what we assume as autonomous workload management. Now, I have started putting some subtopics that could be interesting for the discussion. I think that one big consideration is the workload orchestration. So we need to figure out how we orchestrate the workload in this autonomous manner at the edge. Do we use any model-driven approach? Do we see them hosted in virtual machine containers? We said that before. Both, what is the expectation there? Is it that we need some specific orchestrator for that? Do we leverage existing ones through the OpenStack portfolio of services, or we need to see something which is more streamlined, more edge-oriented? So those are some maybe open questions to start the discussion with. The other point that probably we could touch is the state. So again, if we want autonomous behavior, something needs to track the state at the edge of the state of the workload potentially. Do we keep the level of the state tracking at the hosting environment, at the VM or the container or the VNF, or we see something that we need to be at the service level? So what is the workload that we want to observe? What's the state management? Which is, I think, it's quite important when we're considering the autonomous behavior. So I think it's something that it might be tackled with existing technologies, but I believe that we need to do more things. We need to define protocols, especially the vendors, the VNF vendors. They need to maybe think how they could track the state in a universal way, not explicitly with their own version of the VNF, but more collectively as a community to define protocols for state management that would facilitate the autonomous management at the edge. Policy, again, this goes close with the state. We need to react at the edge. We don't afford to go back at the central orchestrator or a central control component to see what we need to do and then react. So I think also policy is very important. And then is the repositories, right? If we want to spin up things in an autonomous manner, we need to have them in hand locally and not bring them from a remote. And this is very relevant, I guess, with mobile use cases, or in my interest, let's say from Inmarsat perspective, where there is even a satellite link, which is super expensive. So those are some just pillars for discussion, which we could start further exploring now. And also, if there are other points, feel free to put it in the Etherpad to discuss. First of all, I mean, maybe some comments from you guys, whether you see the autonomous behavior of the edge to be a driving force for the actual edge computing topic, or are other topics like how we define the use cases or what will be the footprint? I mean, is it something that, from your perspective, when you think edge is a priority for you to define the autonomous behavior, the autonomous orchestration of the workloads, or do you expect, as technologies of this domain, that will be something that the vendors could deal with that on their own, and it's more of a application-specific topic rather than a platform topic to address? I mean, that could be something to have a comment. And then I don't know if there are people involved with activities like Tacker or other orchestrators that they could embrace the Tosca perspective, that they could have a word on how they see that playing a role in the orchestration, the autonomous orchestration of that of the edge platform. Any comment to start with? So in specific of these 4 pillars, or any other topic that you think that could start with? All right. So maybe just, again, I think we could start with use cases, as was mentioned before. So I will start with our experience and why I think that the autonomous workload orchestration could be actually one of the main points of the edge platform. Is that we need to ship. I mean, even in the as Beth said, in the Verizon cases, that you have to ship the whole CPE device and be able to bootstrap the whole thing from the system level and then up to the workload in order to be able to have the VNFs provisioned and orchestrated. So you have to have all the necessary software stack in place and all the necessary templates in order to allow the whole system to come to a live, to call home potentially, and to be operational. You cannot expect that connectivity will be all there. I mean, someone wrote here that, yes, you have unreliable edge to DC or edge to core communication. Latency could be an issue in many use cases. Or you have to put some sync mechanism between the edge and the core in order to start some heartbeats and check the state of the edge. So the scale of the whole edge vision is, I believe, a main reason that autonomous behavior of that platform needs to be supported. So we cannot expect or assume that we'll use the same control plane means as we have now in OpenStack to orchestrate centrally all the workloads that we have at the edge. So we spoke about remote edge before. Yes, could be a case up until a scale range, but in the vision of the edge platform and the edge computing, it does not apply, in my opinion. You need autonomous behavior, you need autonomous bootstrapping of the system, and you need autonomous workload execution. You cannot afford having synchronization, or you cannot afford having a central point on orchestrating the workloads. So I think that the number one use case here is not the remote edge scenario, but it's the actual mobile edge scenario, where you have the last mile, the last hop is closer to the user. There are use cases there. I mean, I've seen could be augmented reality could be one that was mentioned before, or analytics at the edge that you want directly to have it there, or mobile edge scenarios where connectivity is not given as a SATCOM scenario or the mobile compute scenario. So there's another one. Why not? Yes.
So given the scale, I think the workload management of the stuff the owner of the edge equipment has to be automated. Provisioning VMs, containers, et cetera, monitoring all that, calling for help when they need to. And then I think given the diversity of applications that the people who rent that infrastructure will create, it's probably hopeless for the owner of the edge equipment to try and do the workload management. Rather, they need to provide the tools necessary so that the people renting the stuff from them to run their own VR, AR, whatever applications, they need to provide them the tools. So metrics to determine when do I need to request more infrastructure, et cetera. It seems to me that's the logical split. Would you agree with that, or is it more complex? Am I oversimplifying?
No, I think if I get it right, I mean, I think I agree. I think that it's a valid point that the management of the infrastructure and the ownership of the infrastructure could be a different thing from the management of the workload. So I think it's in our experience, it is an actual industrial problem, let's say. It's a challenge that there might be, that the owner might be, so for example, an example, you sell a CP to a customer, and he owns the whole device, but as a provider, you might have your own platform there, and you manage the platform yourself for some VNFs or some services. So this split ownership issue is realistic. It's problematic in a way because we cannot necessarily have full control of all the resources. And I think it's a super valid point that designing a platform or a system to provide and offer services at the edge, we need to have models and reference architectures that cover this use case. So architecture of full ownership of the CPE or co-location of the platform with something else, with resources of somebody that owns the CPE.
So what, in this specific case, your sentence is there, what do you mean by CPE? I mean customer premises equipment, but what specifically would that be?
Could be from whatever, a cable modem to a rack of x86 servers that they sit on a vessel or on an oil rig. It depends on the industry and the scenario. But I would say in my mind, it's a big variety from very thin Raspberry Pi-like of footprint devices to more big server-like CPs.
So, just a comment to the gentleman there at the back. I think there's a difference between automated processes to autonomous behavior of something. And what we're, I think, still struggling to understand in this larger context of edge is how do I create an autonomous behavior of the platform at all levels, anywhere from the edge platform itself to the infrastructure that's running on it to the services that it provides, all the way to how applications are packaged, delivered, instantiated, and then run themselves on top of that edge platform. And I think this is we've got ideas, but I don't think we completely figured out how to do this, right? How do you make it autonomous as a mobile phone, right? You know, any kid can develop an iPhone app, and this will magically appear on your device, and it will just work. And whoever wrote this app doesn't even need to understand how this kind of edge device runs on. When we're looking at edge computing use cases, these applications are now just being developed. Yes, some of them are traditional VNFs, networking, but a lot of these new IoT applications, we don't even know how they're going to look like. So how do you build that level of autonomous thinking that can scale incredibly, that can heal itself and fix itself and, you know, instantiate itself and understand what resources are available and how that can map to autonomous, which is, like I said, is a big word.
Yeah, I mean, it's quite brand, it's quite a new topic and new territory, but the scale, I think, will drive it, and the scale will push the technology to become more autonomous, to be able to heal, but in more directions than we assume heal now. So that's why I think policy and state play a role, and the granularity of that should go further than the granularity that we assume today in OpenStack, for example. So we need to be able to react in events that might have to do with the application itself, with the service itself, and not just stay at the level of the resources. Because when you ship something on the edge and you don't control it, you need to have something to take care of that. Yeah.
Yep. So just a comment. We've got a couple of use cases up there, and it sounds like yours is an interesting one that isn't up there. Can you maybe clarify more what you're actually trying to do with the capabilities that you just elucidated?
So we're coming in from the application orchestration point of view. So I'm thinking, okay, there's an application, I need to now instantiate it and manage it. So traditionally, if I'm working against a target cloud, OpenStack, you know, VMware, Amazon, then the way that as an orchestrator we understand these challenges is quite understood problem. I know how to manage these applications. We've got the full control of the stack. In an edge computing situation, it's almost like a fire and forget. I'm instantiating an application that is essentially going to land on a very remote piece of hardware somewhere that I don't have all of the management infrastructure or stack around it to be able to understand if it fails, if I need to do something. You know, I don't have massive service assurance system around me that tells me, yes, it's working and it's fine. In many cases, those edge devices are built on very thin control kind of layers, and I'm, in a way, delegating the responsibility to that node. So this is kind of where the autonomous needs to come, the way that kind of I understand it. And a lot of it will come from the infrastructure that it runs on. A lot of it also is how the application itself is designed and whether or not there's a local orchestrator at that edge that can actually understand the local behavior. Yes, I need to do something, or if I cannot do it, maybe I need to now escalate it back to kind of a master orchestrator. So yeah. I don't know if it answers the question.
Yeah. So yeah, I think that's a good point. Also in the context of lack of connectivity, where depending on the edge application, Somebody pointed out management of workload may be different than ownership of edge infrastructure. So in a disconnected state, what does that mean? Can the person who is present while the device is disconnected, are they able to orchestrate? Are they able to do stuff, and what subset of stuff should they be able to do? Because so there, going back to 2 sessions ago, there's the difference between there's global orchestration, there's local orchestration, but there's also an interesting potential mix there, which adds to the complexity.
And just to comment on that, I think it's more than just whether I have connectivity or not, right? Sometimes the nature of these applications is so real time that even if I have connectivity, the question is, okay, do I want to go back to a centralized decision, source of truth to make a certain application decision? And the more intelligence we give these applications and the edge nodes they're going to run on, the better the architecture of the application is going to behave. Obviously, when there's no connectivity, that's an extreme case.
I mean, that's, as you said, I mean, the connectivity is quite of an important point. We need to ensure that the operation of an edge device, an edge platform, an edge mini cluster would proceed even if you lose control plane, if you lose the networking between that edge and the core. So another assumption that maybe it's correct, maybe it's not, is that whether we see actually the edges to be absolutely independent, or there is, even if they are autonomous and they are self-orchestrated, if they are still part of a centralized infrastructure. So they heartbeat in a central control system, and they make themselves available. So this is another point. I mean, actually this is driven again by use cases. Whether we see use cases about absolute independence of edge computes, or are operating in an autonomous manner, but they are part of a collection, of a cluster, of a bigger part.
If there is a node that continues to run at the edge, if you don't have the heartbeat, then if you revoke some privileges, it will not be able to update it. So I think in order for security, there has to be a constant heartbeat. The edge cannot just spin off and run by itself.
That's true. That's true. But again, we need to have. I believe that this needs to be the protocol of that heartbeat needs to be defined. The frequency or the throughput of that needs to be variable, needs to be very efficient, in my opinion. So we need the central. I believe that we cannot have absolute mesh-like autonomous edges. I think again, we are very far. Could be a nice scenario, a nice vision, but realistically, from today where we are, the centralized cloud technology community, to go to an absolute mesh-like autonomous edge, I think is a far, far away. So I guess, yeah, it's correct. We need to gradually go in a cluster-like edge computing platform, which, however, needs to have very autonomous behavior and protocols.
Maybe the heartbeat can be longer. Updates every 15 minutes or 1 hour or something.
Yeah, I mean, that is it's more implementation specific, definitely. The other part of which potentially could bring some discussion is about the state. So I don't know if we have vendors here of VNFs that they could comment on that, on how they see their experience on defining the health of a VNF, or want to track the health of a VNF is being done. I mean, again, from architectural perspective of the platform, I think that we lack of protocols in that NAV infrastructure space, I think we stop at the state of the hosting environment, of the VNF. When we say VNF, we assume it's a VM. But I think that if we want to succeed in an actual autonomous behavior, we need to move more within the service domain and capture somehow the state of the actual workload in a universal way, in a way that the platform could understand and react. So I think that is a direction that we should invest time as community, and maybe come up with some draft specification or guidelines how the vendors that will prepare VNFs to be hosted on these devices to define some patterns or some protocols of health reporting that will be compatible with orchestrators of that edge. Right.
Absolutely, I agreed with you that VM level determination is not sufficient. Now, if you go back, you have Negio older days at the service level, but they are non-virtualized. And so depending on how we use, whether it's container at the edge, or is it the VM or container within the VM, the combination thereof, we will have to come up with some kind of events or messages that can be aggregated from these applications, and then it could be time series, or it could be some kind of aggregation, and then the alerts being set, which we do have, but how do we make it for the footprint that we propose in the edge cluster? That will be critical.
Yeah,
and the state can be attached and detached like any other storage component, but that also needs a specification as what is that footprint. And that is another key element. Thank you.
Definitely. As you said, I think the state could be considered in that scenario, even in a kind of a microservices paradigm. I mean, you can expect that the workload at the edge could be a collection of different components. So again, I see that the state definition of a server, of a workload at the edge, could be a combination of different other states. You can define the state of the resources, you can define the state of the connection, you can define the state of the application. So you have different layers of that. It's a composable thing that you could and you should keep the track of. So again, I think that there are different, you should see the problem as a multi-layer problem. So having the management and the state and control domain of the system, of the platform, then we could move up the layer and we have the hosting environment where you speak about VMs or containers or the packaging of that. So you have state there, and then you have on top of that the workload of the service. So again, you need to have state. So state tracking and policy definition needs to be in my opinion, in all those tiers. You cannot have only the one. So it's more complex than we might see that now.
I was just going to mention, related to kind of monitoring the application inside the VM. I've been working a bit with OpenFE and the Mazakari group, which is high availability VM stuff, and we've been working a bit on well, specifically for VMs, defining a protocol over like a serial interface through QEMU, basically to probe the state of the applications inside the VM. The protocol itself is really simple. It's just, you know, I'm good or I'm not good.
Right.
Internally inside the VM, he could choose to the application could choose to be as complicated or as uncomplicated as possible. He could just, you know, reply to the heartbeat, and it'd at least detect like if the kernel's hung or anything like this. Or it could be more sophisticated and say, oh, are all my applications healthy, and do some sort of even audit check and stuff like that. So the blueprint that we've done in Mazikari is just to propose that that you can enable that type of, I think that we called it intrusive VM monitoring, and then we report it back through Vitrage or whatever to have somebody react, like maybe just restart the VM if it's hung or something like that.
And is it something that, is it some kind of a library that you expose to a potential vendor in order to consume it and report, or how you?
Yeah, it would be like we were proposing that. Well, we're using the QEMU guest agent capability, which is in the QEMU open source upstream code. But then proposing that we'd provide some kind of example libraries on how you could reply to the. That implemented the protocol on the guest side, basically, and then, but anyways, yeah. So I was just going to say that we kind of thought similar things around wanting to get kind of internal, a combination of both the hosting entity as well as the application inside the hosting entity.
No, that's great. It's exactly that direction that we need to have something extracted from the application, and if it is standardized and formalized, that's the best way, because that's the way to be adopted by all the platforms and all the application vendors. Yeah. So it would be great if you can put also some link on the Etherpad so we could
Sure. Yeah, there was some other stuff we looked at as well, but it was thought as too far-fetched. But we were doing things like even being able to kind of ACK or NACK Nova commands or something like that. Like if the guy was trying to pause your VM or something like that, and you weren't currently synced with your peer at an application level, it could NACK the Nova pause or something like that. But those aren't in the current blueprint. But
right.
Anyways, just thought I'd mention it.
Oh, that's very useful. Thanks. Right. I see some comments on the policy having security and fault management, of course, and SLA and personalization profiles. In the policy section, again, that's, I guess, also quite important. You need to is actually how we react. So we need, at the edge platform, we need to react locally. So this is, again, another driving force, I think. Having the compute closer to the user is not enough. We need to have the policy and the actuation close to the user, and not expect that the policy will come from a central point. So I think that we have also there's a gap in the technology and the platforms, and also in the OpenStack in that sense. I guess that policy engines and policy frameworks need to exist in a layer on their own, outside of the resource managers or the resource orchestrators. They need to be able to define event-driven policies, resource policies, or even application policies. So I think that it's something we also, in Inmarsat, we are working on that topic, and we believe, we are spending some effort on creating some frameworks on top of the existing orchestrators that could react on events. Now, maybe we spend some time on the. Have a comment?
Just wanted to kind of get your thoughts on the security thing. I think we haven't really touched on that at all. I think security is going to challenge all of us in this industry about how edge computing is going to affect the way that we secure applications or data centers. Today we work in a very centralized way. We put everything in the center and we build, massive security around it, and we still get hacked. So how are we going to do that, that instead of managing 10 data centers, we've got 100,000? You know, we just don't have enough people to secure these things. So that for me is a very interesting thing to start to understand. It in a way ties to autonomous, because an autonomous behavior of something is not just the way it manages itself, instantiates, it's also how it secures itself. What if it gets breached? Can you build something that understands that behavior and actually does something? You know, isolates itself, takes itself down, disconnected from it, the rest of the network. So it'll be interesting to, I don't know if there's anybody here from security vendors, but to kind of get some opinions on what you're seeing, what you guys thinking about this.
It's very interesting, because I mean, imagine that at the edge platform side, the whole device could be breached. I mean, you don't have hold of the device. So
physical security, right?
So let's start from that part of the security, not even fancy hacking or anything. I mean, the whole device could be stolen if it is a mobile CPE or of some sort. So how we, from the provider's perspective, how we ensure that the whole platform is absolutely secure and can be used only by the person that's supposed to be used. So I guess, yes, exactly, it's an additional challenge. For that, maybe we cannot avoid having some centralized security authentication mechanism, or we need to come up with ways that the security exists in some kind of encrypted way at the device itself.
And there actually is a session tomorrow morning on security, and so I think that you know, that would be a good place to try to dive into that, because I do think that is a huge area of differentiation between data center clouds and you know, doing all this computing in all kinds of random areas. Yeah,
and for that, I think there have been ideas we were discussing with some folks, ways that you can unlock, let's say, the device using actually physical means with a USB fob or something. So there are multiple aspects on how security will need to be enforced in the edge computing platforms. Right. If there are no other points for the policy for now, we could start exploring a little bit how the whole caching and the local repositories could look like. So in that part, I mean, when I started writing the notes for that, the idea is, again, in the simple use case that you give to somebody a universal CPE of some sort, and you expect that the whole environment will bootstrap itself automatically. The initial workloads will be provisioned automatically there. So the expectation is that the delivery mechanism and the repositories and all the packaging that we need for building the edge platform, but also supporting the workloads, needs to be present locally. So potentially needs to be persistent or to be cached. There are open questions whether we can afford that kind of storage there. Do we have only the latest version of a package, or do we keep history, or how we do a reset of the whole thing? So we might need to dig to the existing mechanisms and the services that OpenStack uses and try, or Kubernetes or whatever, or Docker packaging, in order to see how, if we can leverage the packaging mechanism and the repositories that exist today and have that in place. But I think that it's quite crucial to assume that there is a local presence of all the files, of the templates, from the workload provisioning down to the system bootstrapping level. All this needs to be locally present in the actual mobile device or CPE device. The other point that it's, I guess, relevant that I would like also, if there are consideration from your side, is about multicasting features. Whether, assuming again the scale of the edge vision, whether there are protocols in place with repositories or technologies existing that you could push out massive updates to the whole cluster. Because again, I mean, some vision is that you have a whole cluster of devices. There are, I mean, I don't know, potentially that could become a challenge, or how you enforce it, or how you manage that at the edge. That's a very, from Inmarsat again perspective, that's a very valid point. I mean, having all the terminals, we need to be able to push out these updates and these files to the terminals, to the edge platforms. I see some comments here, standardized images. Yeah. And again, I mean, the other consideration we talk about OpenStack or containers, I think both is a realistic expectation, that we cannot assume that will be the workloads at the edge will be absolutely hosted on virtual machines or will be only in containers. I think will be both, assuming that the vendors are at the moment based on VM implementations, but the expectation is that this will gradually change. Okay. There are some more comments up there. Deep sleep. What somebody wrote about that? What exactly is the use case? Just some comments there. Would be interesting.
So in our situation, our edge nodes are actually very expensive to power. And in the event that orchestration isn't really getting messages through, or it's not able to actually communicate with anything else that it needs to, we'd very much prefer it if it could either go to sleep or turn itself off, because it is a physical device somewhere, or it's a part of a physical device somewhere, or if that gives it room to just free up and find another job if it was an edge node available in an open market in some way.
And do you assume that there will be some, again, I mean, how do you manage that and force it, orchestrate that? I mean, it's a requirement rather.
Well, that's why I would say I very much hope there would be a standard API for it.
I mean, in my mind, I mean, yes, that could be translated either as a policy or an orchestration activity. But definitely, I mean that's an interesting approach. I was coming from a direction that you don't have the connectivity, so you need to go to an idle mode. But this approach, also this perspective, is very interesting actually, because it brings more maybe the IoT kind of the story, which power is very important if you live on a battery or something like that. But that's very interesting. I mean, it's another use case, I guess, another requirement maybe to how to push down all the compute actions in order to save power or go to that idle mode, which I guess brings the IoT perspective into the edge scenarios. Might be far-fetched, but still, I mean, it's...
Our case is not necessarily IoT. It's
okay.
just for very, very large machines that just happen to exist far away.
Yeah, I see that.
And
okay,
so
goes
if
both
your
ways.
machine is using 2+ kilowatts, you don't want to leave it on if it's not doing anything. So just having a way to make sure it's like, hey, I should just give up or assign myself to somebody else's workload, that's fair to do. But it's definitely something where, from what I've seen, the conversation here there's a lot of conversation about meta orchestration, And these devices in and of themselves, they should have the autonomy in most cases to be used for something else if they're not being managed by somebody. Mostly because somebody's got to pay the power to keep them on.
Yeah, yeah. A very good point.
Along the lines of deep sleep, if you actually do have an edge cloud device or just an edge device, besides deep sleep, you also want to be able to have a way to wake the device up out of deep sleep remotely from a cloud management perspective, to either suck information out, make sure that you still have connectivity, other things along those lines, but you want the ability to deep sleep to save power, such as batteries. So you need the wake-up call to go along with the deep sleep call.
I guess there are two ways maybe to see that. Definitely you could be from within, so you have a trigger mechanism internally to bring it up again, or you can reach that somehow or enforce it from the central side. But I mean, I guess that this kind of functionality and policy needs definitely to consider how you bring it back, and not only how you get into the idle mode. Another also point that is, I think it's relevant with all these things, assuming again the networking and the connectivity, is whether we have some kind of queuing system. So how we bring back metrics or information that are generated at the edge, how we bring them back. So do we assume that we have a constant way? Do we leverage APIs for the communication edge to core, or do we want to use more of a kind of a queuing and messaging technologies and protocols? I mean, again, it goes back to the synchronous versus asynchronous communication between edge and non-edge control planes. So potentially we could start exploring protocols for asynchronous communication for the control plane, so not existing APIs, or see how the APIs could be pushed through queuing systems, or you could pass control plane commands in an asynchronous way, assuming that you do not have direct connectivity constantly at the edge. So that's another point potentially for the orchestration. Now, data workloads, right. Yes, that's another point. So we said about the repositories at the edge, hosting the images for the workloads, for the system bootstrapping. But indeed, if we assume that the workload itself is a data-driven workload, we need to have local hard drives. Yes, we have what we can have, but might be not sufficient. So again, that's another point for having a combination, a hybrid mode of edge to core. So that comment potentially is leading on use cases that the edge collaborates with a service at the core network. There is a copying or moving data from the local buffer or the local cache to a cloud-enabled data center-enabled service. So I guess this could be commented with an additional, with a specific set of use cases where we need to have a hybrid mode of workload operation, autonomous at the edge, but also going to the DC and copying data over there. It's deployed in each I guess that some sort, for this comment, I guess that some sort of data service needs to be deployed at the edge. I think that's inevitable. And we could explore Swift for sure, or other options.
Time check, 10 minutes left.
Right. So going back to the point, maybe to wrap up or try to find some action points. I think that we need to check the workload orchestration options existing in the open source community, relevant with OpenStack for starters, and also other platforms. We need to see what the industry prefers. I mean, there is clear, in my opinion, there is a clear tendency towards model-driven workload orchestration. Projects like Tucker or Cloudify or OpenBato, and all these efforts are converging, OwnUp as well. So I think it's a direction that definitely needs to be strengthened, coordinated, and I would expect that as the outcome of this two-day session, there needs to be some activity, some coordinated activity for the orchestration of edge use cases. So this is potentially a request, let's say, or somehow if we can group those folks together and try to see if there is any difference in the model-driven orchestration for the edge use cases compared to the cloud data center ones. So I think that could be something. Maybe you could start exploring, I mean, again, exploring all the efforts with the use cases to try to see the problem from the modeling perspective and orchestration perspective. For the state and policy, I would say that Inmarsat will be willing to give some use cases and ideas on the parts that we are working on. So could be mentioned as an action there that we could in the following weeks and months to put something together as maybe in an Etherpad with some ideas on how we tackle the policy in the projects that we are working on. So this is something that could be mentioned as a potential action. Sorry? I think the actions will be at the bottom. Right. Or not yet. So yeah, for the local repositories, I don't know if there are guys with projects, relevant projects that they could start collecting some thoughts and keeping some notes. Would be useful. Any other point that you think that would create some activity or could be interesting for the workload management, for the autonomous behavior? Something else that we could keep some notes for this session? Right. I think we got exhausted by the... Cool. So we are 5 minutes earlier. We could close this thing up.
So we'll have a 20-minute break now, and then we have additional, I don't think it's breakout sessions. What's the seminars? Yes. 2 seminars, one here, and then one on the floor above. Please make sure you drink water, as it is a little bit warm, humid, so please do have a drink. Just quick round of applause for our moderator. Thank you so much. See you back in 20.